Hello and welcome to another video. In this video, we're going to be working on find closest node to given two nodes. And in this one, you're given a directed graph of n nodes numbered from 0 to n-1, where each node can have at most one outgoing edge. And a graph is represented with a given zero-indexed array of edges of size n, indicating there's a directed edge. And if there's no outgoing edge, then there's -1. So essentially every edge, so like here 0 has an edge to 2, 1 has an edge to 2, 2 has an edge to 3, 3 has an edge to nothing. You're also given node 1 and node 2. And you want to return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance of node 1 to that node and node 2 to that node is the smallest. If there's multiple, return the one with the smallest index. Note that edges can contain cycles. Okay, so let's walk through this. So here from node 1, which is 0, this has a distance of 1, this has a distance of 2, and then from this one, this has a distance of 1, this has a distance of 2. Also, a node is 0 distance to itself, but you can't get from 0 to 1, you can't get from 1 to 0, so that doesn't work. So the answer here is 2. And then second example, so node 1 is this node, and node 2 is this node. So here we have a distance of 1, but we can't get here from 2. Here we have a distance of 0 from itself and 2 from this. So this is the only node you can get to from both. So this one's kind of straightforward. Essentially, like if we have some directed graph, we can basically just calculate, like we can just do a BFS or just traverse from node 0 to everything else, or node 1 to node 0 to everything else, and get that distance. So imagine we had something like this, and this happened to be node 1, and then maybe we'll have some stuff. So maybe node 1 can go, like this way, and then this goes this way, and then this goes this way. This is node 1. So here, basically, we'll say like, okay, this distance is 0, this distance is 1, 2, 3, and so on. And we can just write that down. So for the given index, what's the distance? So here, this might be like index 0, index 3, index 4. And then we can do the same thing from node 2. So maybe this is node 2, maybe it has this, something like this. And maybe this has like over here. So we can say like this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and so on. And then we just check like what's both of them. So in this one, this is going to have 3 and 3, and so the maximum of these is going to be that. So basically, for every node, we can just make like a dictionary of like node 1 distances. So this will be like the node that we're reaching and the distance, and then we can do the same thing for node 2 distances. So same exact thing. So we can have like a dictionary here, or map, node we're reaching and the distance. And then for every single node in, maybe this is like node 1 dictionary, node 2 dictionary. In the node 1 dictionary, we can just say like, okay, for all of these, is it in the second one? It has to be. And is the distance minimized? Like we have to take the maximum of the two distances and just take the one that takes the smallest. And if there's a tie, then we'll have the one with the smaller value. So it's not even like a BFS because every node only has one edge. So essentially we're just traversing like one node at a time in this path until we either run out or we hit like a cycle. And we can check with the cycle by getting this distances dictionary. And that's basically it. So let's code. Okay, so essentially we're going to make like a map of node 1 nodes and node 2 nodes. So I'll just call it like lefts and rights, but it's the same thing. Sure. Or we can call it, so we can say like node 1 nodes, this, same for the other one. Maybe do it this way. Node 2 nodes. Okay, so we're going to make a helper function that's going to take the edges, the node we're starting from, and this map, and it's going to fill out the map because we're going to need to use it for both. So let's do that. So one compute distance. It's going to take edges. It's going to take the start node and the map. Distances. Okay. So we're going to calculate the distance. So it starts off with distance 0. So we're going to say distance 0. And basically, like, we can just keep traversing until we either hit a -1 or we hit something we've seen before. So we'll start doesn't equal -1, and distance does not already contain this, because this is basically a visited set. Contains or distances contains key of start. So while we do this, let's keep writing it in. So dist put start distance, and the distance is going to increase every time. And then we're just going to get the new start. So edges start. And we can call this start, we can call this cur, whatever distances. So this is going to fill out our stuff. So let's call this twice. So compute distances, we're going to call them edges start and node1 nodes. I guess that's not going to be start, it's going to be node1 here. And same thing for node2. Okay. And then we're going to get our best result. So maybe we'll say like our node is -1 and our distance, our best distance is, we'll just make it infinity. And we're going to loop through everything in the left, check if it's in the right, and then if it is, then we're going to minimize. So let's say var entry, what's entry set. So, or I guess not left, called it this. So int key equals entry get key. And we're going to get the left value. So the left value, or the node1 value, is going to be entry get value. And then we're going to get the right value as well. So int right value will be rights get. We can use a getter default. So if it's not there, we'll just return like infinity or something. This is node2 values. Node2 nodes. Okay. Getter default. The key and the default can just be max. And then we're just going to say if the max, or I guess we have to calculate this thing, right? So int max dist equals max of the, let's see, I guess this is the node2 value. So node1 value and node2 value. And so if the max dist is less than the dist, which is like our result dist, or they're the same, but the node is smaller, which is the key, then we're going to replace. So dist will be max dist, and the node will be the key. And so if you never find anything, we'll just return -1, so that's going to kind of work out. All right. See if we get any errors. Nope. Okay, great. Okay. So I think to make this faster, you probably need like an array or something, typical Java, but this is fine. So sum up, what did we do? We did a BFS from node 1. So worst case, obviously it's just going to be like a linear path where you traverse everything. So that's going to be O of n, where n is the number of nodes in the thing. And that's worst case going to be O of edges, I guess. because you can only have like edges at the most. Okay. Yeah, I guess the number then yeah, I guess I could have used an array and not thinking about it because this edges is like node 0, node 1, node 2, node 3, right? So edges is always the length of the number of nodes. So we can call this like of n, where n is the length of edges. And then space is of n as well. So yeah, maybe that would have been better. Yeah, I didn't think of that. Is we instead of using a hash map, because these edges are 0 to whatever, we could have just used arrays and that would have been faster. So that's something to think about in the future. But yeah, it's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.